is I want to talk with you about the end of third quarter, because we are now finally at the end of third quarter. So guys, with the exception of Liam and Aslan's tests, third quarter is done. All of your tests have obviously been graded. Your homework is past due. All of your late labs and your extra credit have been recorded. And guys, it was actually pretty cool. The number of you that were close to a grade break, like a B plus, and that extra credit kicked you up to like an A minus, or even in a couple cases, you were so close to that A minus that you ended up with an A. Yeah, guys, extra credit is always a beautiful thing, and it was neat the number of you that did it. Guys, with that said, remember third quarter is actually not completely done. And the reason is because we are pushing remediation till after the long weekend, which then technically is fourth quarter. But guys, we've got this weird week because we don't have school on Monday, and we can't do remediation on Wednesday because it's a short day. So guys, we're going to have to do this in two days. So if you qualified to do remediation, got less than 75%, and didn't master all the essentials, guys, the only shot that we're going to have for doing remediation is Tuesday after school. And guys, I get it. Spring sports start on Tuesday. Lacrosse starts on Tuesday. I'm sure other sports are spinning up on Tuesday. So if that doesn't work for you, that's fine. You just need to talk to me. But then, guys, the essentials test will be on Thursday. And then assuming that you master these essentials, I'll go back and do a grade change for you. And I'm happy to do it. The thing that's missing right now is the essentials stuff is not posted. The remediation stuff, I will post this before I leave today, and we'll be all set. So, guys, again, you know the deal. I love talking with students about grades. If you would like to talk about your third quarter grade, I seriously, and I enjoy these conversations. But guys, remember the deal. It's by appointment, and it's not today or tomorrow. We make appointments and we sit down and talk after break, after the 3-day weekend. But guys, if you'd like to chat, I'd love to sit down with you. Frankly, if nothing else, I just love getting time to talk to you. So, guys, please come by. I would love that. So, guys, any questions about the calendar? Any questions about where we are relative to third quarter? You guys all good? Are you guys done in all your classes? No? Yeah? My daughter was up to like 2 a.m. writing papers. I had no mercy for her because they were papers that she's known about for weeks. So it's her own stinking fault. But anyway, we're good? Okay. So then, guys, the next thing we need to do is this. Grab your homework packets. We have not yet looked at these, so let's spend a second. Let's look at homework assignment number 1, homework assignment number 2, with the understanding that we cannot record these because they go in fourth quarter's grade, and it's not fourth quarter yet. But guys, let's at least look over them and make sure that we're clear on how these work. And then, guys, we will record performance scores when I see you again on, I think, Tuesday. Wait, what's today? Friday? No, Wednesday? When do I see you? Wednesday? All right. So, guys, on this assignment, let's talk. What we're doing is we are figuring out the formula masses of these compounds. Guys, a couple important things to remember. First of all, we are rounding to 1 decimal place. That is our general rule for now. That's going to change in about 15 minutes. But guys, right now we're rounding to 1 decimal place. In addition to that, guys, please remember that our units are atomic mass units. Guys, interestingly, we learned back in September that an atomic mass unit is the mass of a proton. So guys, if we've got calcium acetate, that weighs the same as 158 protons. So guys, these are very small masses, but those are the masses that are on the periodic table and therefore the ones we need to use. So guys, do you need to talk about any of these? You okay? Also remember this, my hope was that you didn't need to write down these tables, but instead you just wrote calcium's 40.1, carbon is 12, this is 1 times 3, 12, 16, and guys, if you just write the stuff above, it's so much faster and easier. So guys, I'm going to page through them, check your answers. Is that all of them? We did all of them, yeah. More? Hey, now we're done. Guys, any questions on this? Okay, so write a reminder at the top of your page. Is it done completely? Did you have it done right now? Just write yes if it's yes or no if it's no. And I will gather these scores up the next time I see you. You guys good? All right. This goes away. Kerplop. And assignment number 2. Guys, as I told you last time, these are the dumbest questions you've ever answered in your entire life. We really don't care how many grams are in an ounce. We do kind of care how many centimeters are in a meter because it's sort of important. But, guys, at the end of the day, you're never going to solve problems like this ever again. These are gone. We're done. This was a process and not a product. So guys, let's remind ourselves of the process. We start with a goal, and then we determine our starting point. Then we ask ourselves this question: how many meters make up a centimeter? And we turn to our conversion chart, and we find out that 100 centimeters are a meter. Then when we apply that conversion, we say, okay, if centimeters are up here, centimeters have got to be down here. And so these cancel top to bottom, leaving meters on the top. So we cancel the centimeters, then we know meters are equal to meters, so we know that we're done. At that point, we do the math. We multiply by everything on the top. The 1 doesn't matter. Then we divide by the bottom. 14 divided by 1 is 0.14. Then we round to significant digits. This is 2 significant digits. This is perfect because it's a definition. We use the fewest. That gives us 2 significant digits in our answer, and that 0 is not significant. It's just a placeholder, so the decimal place stands out. So guys, at that point, turning it back to you, what questions do you have on any of these? I'd love to go through them with you. Yeah?
I have a question about the list.
Okay.
With the conversion.
Please. Yeah.
With the length.
Yes.
Symbol.
Let me grab a copy of the conversion chart. Yeah, go ahead. What are you seeing?
With the, I don't even know what it is.
Yeah, well, I mean, I think probably the length one's feet, yards, miles, you're good. But yeah, what is a DM? What is that sexy little U-looking critter down there at the bottom, right? At the end of the day, it doesn't really matter. I'd be happy to tell you that U-looking critter is micro. It means millionth. So there's 1,000,000 micrometers in a meter. And then the one that's down below that, the A with the halo on top of it, is actually angstroms. Those are 10 to the negative 10th meters. So it takes 10 to the 10th of those to make a meter. Very, very. So what do we measure in units like angstroms? And the answer is bond lengths. Do you remember when we talked about adding up the covalent radii and that gives us the bond length? Those covalent radii on the periodic table are actually in angstroms. So when we measure the size of atoms, we do that in angstroms. So yeah, there's some information on there, frankly, we're not going to touch. But yeah, it's neat you were looking at it. Yeah. Guys, what else? So guys, this then is the commitment that you're making. By not asking questions, you are screaming at me, I'm comfortable with this process. I understand goal. I understand starting point. I understand conversions. I understand cancel top to bottom. I understand making sure that my units line up with my goal. I understand multiplying by the top and dividing by the bottom. And I understand rounding to the fewest significant digits. Guys, if you can't say amen to all of those things, you need to be asking questions right now. You okay? Is that a corporate amen? All right, so guys, up at the top, yes or no? Did you get this done? And then guys, you can just close up your homework packet and slide it to the side. You'll be just fine. Don't put it away though. You're going to have time to work on your homework today. Oh guys, here we go. Get rid of this. Get rid of this. Quit out of this. Get rid of this. Quit out of this. Grab a hold of this. All right. So actually, you know what? Hold on. Missed call. Actually, you know what? I'll leave it there. I stole Miss Call's notes on this. So 2 sheets. Yeah, probably 2. 1 for notes. 1 for homework. A pencil, a periodic table, and a calculator. Now guys, here's the deal. If you don't have a calculator with you, you may not use your phone. Typically at this point, if you don't have a calculator with you, I do not lend you calculators. Guys, the reason is this. We are about to do calculations that are very dependent on the calculator that you have. And if you learn to do this on my calculator, you're not learning how to do it on your calculator, and consequently, you're not going to know how to do this. But guys, with that said, probably something is better than nothing. So guys, here's the deal. I am not going to teach you how to use your calculators today. I find that if I try to explain this to one of you on your calculators, I screw everybody else up. We'll talk more about this when we get into the calculations. But guys, right now, I will lend you a calculator if you need, but I will never do this again because you got to learn to do this on your calculators. Who needs one? What just happened? It broke in half. Anyone get hurt? Rebecca, do you need one or are you scared? Oh my gosh, you guys. Who else? Share it. I'm out of calculators. I'm done. Guys, that's all I've got. So, guys, if you don't have a calculator in front of you, shame on you. You know that a calculator is something that you need for this class. Start bringing them. If you don't have one, guys, that means I know you need to go back to first quarter and change your score. Remember that day when we said, do you have a calculator? Do you have a binder? Do you have the things you need for class? Get a calculator. So, guys, if you don't have one, you'll be okay. And frankly, if you do have one, it might even be a disadvantage to you because you're learning how to do this on somebody else's calculator. All right, guys, you ready for this? Big, deep breath. Let me set the stage for you. Guys, you understand a lot of things now about science. Not chemistry, but science. You understand a lot of things about science that you didn't understand 7 months ago. You understand that science is about organization. You understand that science is about patterns and trends and things coming together and building on themselves. We learned about this interesting idea about what electrons do. But then we learned that all these interesting electron structures then lead to the way that they interact and how they form covalent bonds. Why is water bent? Well, we found out it's because of its p orbitals, and 2 of them are half full. And when they fill up with hydrogen electrons, it forms a tetrahedron that then becomes bent. So things build upon things build upon things. But guys, the other thing that you've learned in your science classes is it's great to learn stuff, but if you can't prove it in lab, it doesn't matter. Guys, almost everything that we've done in this class, we have then verified in lab. Even the electron stuff. We went into lab and we did the flame test lab and we looked at the colors and tied those to structures. The longer an electron falls, the higher the energy, the bluer. Anyway, guys, if this doesn't work in lab, it doesn't work at all. With that in mind, guys, here's where we're at. You ready? Just a moment ago, we graded this homework assignment. Guys, we figured out the mass of molecules. And when we calculated the mass of those molecules, this was the process. And guys, we figured out these values in atomic mass units. Then the next day in class, we figured out how to do dimensional analysis. And we learned that dimensional analysis is a tool. Guys, here's what we're going to do today. We are going to use this tool to solve a problem from the previous day's homework assignment that most of you didn't even realize was a problem in the first place. You ready to go? Guys, it goes like this. So we know how to figure out formula masses. Please do this in your notes right now. This is important. Guys, figure out the formula mass of sodium chloride. Remember that we go to 1 decimal place. Remember that if we can, we really try to not do this in grids. We try to do these just by writing the masses up above. But I will solve this in a grid just because that might be helpful. Oh man, somebody took my salt. Do you guys have any salt? That's no fun. Oh, look what I found. Salt. Guys, come up with a number. Verify it with the person next to you. Make sure you're right. It's important that you're right. You guys good? So, guys, did you all arrive at this number? 58.5 atomic mass units. Y'all good? Guys, if you didn't get that number, understand you're either not adding right or not rounding right. We're rounding to 1 decimal place. Sodium is 22.9 something, rounds to 23. Chlorine is 35.45, and rounding to 1 decimal place, that's 35.5, and then add them up. Are we all on the same page? Okay, so guys, now stop taking notes until I tell you to start again. Guys, here's the deal, and think through this with me. If you don't understand what we're about to talk about, then guys, the interesting thing we're going to talk about in a minute isn't going to have a lot of meaning to you. So guys, we've established this idea that numbers on boards are great, but if we can't go do it in lab, it has no value. It could even not be true. If you can't do it in lab, it doesn't count. So guys, we are going to lab. When did Tuesday? I see you. We're going to lab on Tuesday. And guys, when we go over into lab, I know we're sick of working with salt, but guys, when we go into lab, we are going to grab some salt. And we are going to weigh out an amount of salt. And then what we're going to do is we're going to dissolve it in water, and then we're going to add some silver nitrate. We're going to get it to precipitate. The silver grabs a hold of the chloride, and it precipitates, and we're going to do some chemistry. Anyway, in order to do this, guys, what we need to do is we need to weigh out some salt. And you guys all know how this works. You're going to grab yourself a weighing boat, and you're going to put the weighing boat on the balance, and you're going to zero this out, and then you're going to get some salt. But now, guys, we're going to do this. we're not just going to get some salt. We are going to get a calculated amount of salt. How much salt are we going to get? That much salt. Can you picture it? Hit 0, add that much salt, and then guys, when you've got that salt, you're going to dissolve it in water. Does that make sense? Y'all good? Guys, talk to the person next to you about why what I said is absolutely stupid. Talk about it. Liam, I like the tone in your voice. So, Liam almost sounded offended when he was talking about this. Guys, if you don't understand the problem, let me explain it to you. When we say 58.5 atomic mass units of salt, we are not talking about this much salt. We are also not talking about a grain of salt. Guys, when we talk about 58.5 atomic mass units of salt, hold on a minute. We are talking about that much salt. 1 sodium atom, 1 chlorine atom. We can't weigh that, right? So guys, what does that mean? That means that every single formula mass that you calculated when you did homework number 1 is literally worthless to you. Who cares that we know the mass of calcium acetate, number 1? Doesn't matter. It's worthless information to us. So guys, if you're still not clear on why this doesn't work, maybe this. Don't write this down. So guys, what is an atomic mass unit? The mass of a proton. And guys, it's this in grams. This is the mass of a proton. So if we take the mass of a proton and multiply it by 58.5, guys, this is how much salt I just told you to weigh out. Now guys, you don't know this because you're not an AP. Some of you will learn this soon. You know the balances that we have at the back of the room? They're like $300 balances. They're pretty good balances. But they only weigh out to 2 decimal places. Guys, I have balances in the stockroom that I don't let my Gen Chem kids touch because they're $5,000 balances. And they weigh out to 4 decimal places. But guys, the bottom line is in order to get out there, we don't stand a stinking chance. So guys, think through this with me. We have a problem. Our problem is this. These numbers are worthless to us. Where did they come from? The periodic table. But guys, they're worthless to us because they're too stinking small. Get the idea? So how do we fix the problem? Guys, check this out. If we can't weigh 58.5, and guys, don't miss this. This is a critical idea. If we can't weigh 58.5 AMUs of salt because it's too small, how do we fix the problem? Get more salt. So guys, if we get more salt, like this, or eventually like this, or eventually like this, eventually we can have enough of these critters that we can weigh them. Just a second. So guys, the question then becomes, how much more? Now, Nora, if you know the answer, I'm going to ask you to hold off. You got to understand, I'm a chemistry teacher, right? There's very little joy in my life. Don't take this from me. I need this. I need this. Or you could teach. Come on. You going to give this one to me? Tell you what, we'll share it.
Well, I don't know who's right, so.
I don't even want you to be wrong, but we'll come back. I can't let you. This is all I got. I have such a sad life. I just need this. So, guys, Brandon's exactly right, and I think many of you are tracking with this. Guys, if we can't weigh this, what do? We get more. How much more? Well, guys, play along. Don't write this down. This is going to get a little childish. Play along with me. So guys, the question, and don't write this down, how much more? So here's the problem. If we have one NaCl, guys, that group has a name. It's called 1. And one NaCl weighs 58.5 atomic mass units, which is this many grams, and that is not enough salt to weigh. So what do? We get more. How much more? Let's get 12. Oh yeah, 12. Guys, let's get 12. How many, when we have 12 of something, what's the name of that group? A dozen. So guys, if we get a dozen salts, will it weigh more than 58.5 atomic mass units? Please say yes. Guys, 12 things weighs more than one thing, right? I know it's the end of the quarter, but more? How much more? 12 times more. 702 atomic mass units. Weighs this. Not enough. We're not even close. So now, guys, let's get really crazy, right? If 12 isn't enough, we're going full ham. You ready? A dozen dozens. 144. Did you know that group has a name? It's called a gross. That was fine. I know. You can have that one. That one's free. Guys, a dozen dozens is called a gross. That weighs 144 times more than one. It weighs this. 8,400. Now we're getting somewhere. Until you see it in grams, and then you understand it's not enough. But guys, don't look away. Guys, here's what we've established. First of all, AMUs are really small. Second of all, and for some of you this was a mind scrambler, more things weigh more than fewer things. But then guys, we've also established this. Groups have names. 12 is a dozen. 144 is a gross. So now guys, you ready? We are ready to finally answer the question. Don't look away. I'm going to get out of the way. The question is this. How many salts? How many of these do we need for it finally to weigh enough that we can deal with it in lab? Not 12, not 144. Guys, the answer is 602 septillion. Don't steal my thunder. Guys, the answer is 602 septillion. But that also has a name. It is called a mole. Guys, if you have a mole, did you throw out your banana? If you have a mole of bananas, you have 602 septillion bananas. If you have a dozen, you have 12. Guys, if you have a dozen donuts, how many do you have? 12. If you have a mole of donuts, you have 602 septillion donuts. Will 602 septillion donuts weigh more than 12 donuts? A little bit more. But guys, here's then the question. If we have 602 septillion, 602 septillion of these, will it weigh more than 1 or 12 or 144? Guys, how much more does it weigh? This much more. Do you see it? Does that number look familiar? Where have you seen it before? Guys, you've seen this right there. If one thing weighs 58.5 atomic mass units, guys, 602 septillion of those things weighs exactly the same in grams. Did you know that? Then you go ahead and talk, because you're not going to steal my thunder. No, I'm kidding. Go ahead, Adam.
I was just curious, does that mean that 602 septillion is a multiple of 1 AMU in grams?
I'm going to answer your question, but I don't want to talk about it. It is not a multiple, it's the inverse. If you take your calculator and plug in the mass of an AMU in grams and hit 1 over x, you get Avogadro's number. Yeah, and that cool? Yeah. So, guys, this is what we know. Let this bang about in your cork. Guys, 1 NaCl weighs 58.5 atomic mass units. Bitty numbers. If you have 602 septillion of these critters, it weighs the same in grams. Guys, this is a miracle number. So let's talk about it. Guys, write this down. This is what is called a mole. Guys, a mole is a counting group, just like a dozen or a gross. You could have 602 septillion donuts. That's a lot of donuts. But you could. But guys, this number is so important because it allows us to convert directly between atomic mass units and grams. So guys, if you've got a number that is that powerful, certainly we should understand something about the person that came up with it. And his name is Avogadro. Guys, coming back for AP next year, we talk a lot about Avogadro because he actually figured out this number while he was studying gases. And so we talk about something called Avogadro's principle, which applies to gases. But guys, at the end of the day, Avogadro's number is the number of things in a mole. You've got one more thing to write down, and then we're going to stop taking notes again for a minute. So guys, please don't write the next thing down. Here's what we know. Avogadro's number, the number of things in a mole. Let me write it out for you. Guys, this is Avogadro's number. Don't write it down. This is Avogadro's number. Guys, I have a question for you though. How many significant digits does this number have? 3. The 6, the trap 0, and the 2, all the rest of those zeros are not significant. This number is not perfect. It limits significant digits. How far out have you seen Avogadro's number?
I typically use this with
2. I've seen it out to like 7 digits. But guys, and by the way, visiting from BYU, sort of figuring out if she wants to be me, which is a really sobering thought. Again, when the highlight of your life is getting to teach the mole, you may want to reconsider. But guys, what we do is we put this in scientific notation. Uh-oh, my board shut off. Guys, we put it in scientific notation, and you've probably already written it down, but it's 6.02 times 10 to the 23rd. Yes, that's a number you need to know.
The actual number of things in a mole that conversion happens goes down all the way to the decimal point, or is it irrational after the decimal point, or is it?
It's a good question, and I don't know the answer. But what I can do to tie it back for you is, do you remember when we talked about that silicon sphere?
Yeah.
What they're actually trying to do is define the mole. Yeah, and so there's an answer to that question based upon that isotope of silicon, but I don't know the answer. I'm not sure. Yeah, but that's actually what they're chasing when they're, anyway. You guys good on the idea? Okay, so settle in for a minute. Guys, what I'd like you to do, if you're brave, close your eyes. Guys, picture a dozen donuts. Some of you are starting to salivate. Now, guys, what I'd like you to do is this. Picture a dozen donuts. Now you're thinking about inviting friends. Now, guys, imagine 602 septillion donuts. Got it? Guys, here's the problem. We can't wrap our head around numbers this big. They're functionally meaningless. So what do we do with that? Well, guys, what we do is we fall back on analogy. Please don't write any of this down, but guys, check this out. How big is a mole? Well, right now, the fastest, not including quantum computers, but guys, the fastest computers on the earth can count to about 8 billion in 1 second. So 1/1000, they count to 8 billion. Now, guys, how many people are on the earth? Do you know? Yeah, are we... So guys, are we how many? 8 or 9 billion? 8 billion? So guys, here's the question. If there's 8 billion people on the planet, how long would it take a computer to count everybody on the planet? 1 second. 8 billion things a second, about 8 billion people, 1 banana, and that calculator just counted everybody, that computer counted everyone on the planet, okay? Now guys, the question is this. How long would it take that computer to count to 602 septillion? Go ahead. No. It's a number. How long? So guys, I know you can do math, but the math doesn't get you to the point. Guys, a minute? An hour? A day? A month? A year? Guys, how long would it take? Imagine that. Everybody on the planet, every single second. Imagine doing that for a year. Imagine that. If it was one of our Chromebooks, it would crash long before it got there. Right? But guys, doing this would take 2.4 million years. That's how big Avogadro's number. So now guys, what I want you to do is I want you to picture 2.4 million years. You can't. You can't remember yesterday. So let's try something else. I got a little whimsical. A mole of raindrops. Guys, if you have a mole of raindrops, you have 602 septillion raindrops. The question is this. How big a bucket do you need to hold a mole of raindrops? Guys, would it fill the room? Would it fill a swimming pool? Would it fill the field house? Would it fill Cougar Stadium? Guys, this was a stretch. In order to hold a mole of raindrops, if you made a tank that was 100 feet across, guys, this tank would go between the earth and the sun 280 times. That's a pretty tall bucket. But guys, even that is difficult to picture. So what about this? Guys, what if you had a mole of BBs? Think airsoft pellets. Guys, if you had a mole of airsoft pellets, these guys, right? And for reference, this used to be 10,000. Most of these were shot at my son. So guys, if you had a mole of BBs, you have 602 septillion BBs. How big a bucket? Again, would it fill the room? Don't say that flippantly. Guys, think about that. Imagine how fun that would be. This room full of airsoft pellets. That'd be cool. What about the field house? Yeah, imagine the field house full of airsoft pellets. That's pretty cool. So guys, how big a container would it take to hold 602 septillion BBs? We've never been to the sun. The raindrop thing is stupid, but we all live in Utah. Here's the deal. If you had a mole of airsoft pellets, and if you could turn the state of Utah into a Tupperware container, put walls around it, flatten the mountains, fill the valleys, make the bottom flat, and make it into a Tupperware container, guys, it would bury the state of Utah 253 feet deep. The whole state. 253 feet deep. You get in the sense that this is a pretty big number? So guys, now let's take it into chemistry. What if you have a mole of carbon atoms? Guys, think about this with me. If you have a mole of carbon atoms, how many do you have? Don't look away. If you have a mole of carbon atoms, how many do you have? If you have a dozen carbon atoms, how many do you have? 12. If you have a mole of carbon atoms, how many do you have? 602 septillion. Guys, how big a container do you need to hold a mole of carbon atoms? And guys, the answer is this. This is it. This is 602 septillion carbon atoms. If these were as big as BBs, they would bury the state of Utah 253. You get a sense of how small atoms are, right? But guys, how do I know that this is 602 septillion? Did I count them? No, it'd be 2.4 million years. I saw what you did a minute ago, Adam. I know you know the answer. How do I know that this is 602 septillion carbon atoms? I weighed them. Guys, this is 12 grams of carbon. Do this. Look on your periodic table. Guys, this is 12 grams of carbon. Now do this with me in your head. One carbon atom weighs 12 AMUs. So 602 septillion atoms weighs 12 grams. Guys, all of a sudden those numbers become meaningful to us because we can weigh grams if we count in moles. So guys, let's get this in our notes as a foundation for what we're doing. Please write this down. Guys, one carbon atom weighs 12 AMUs. You knew that 2 class periods ago. So if if one carbon atom weighs 12 AMUs, this is also true. Avogadro's number of carbon atoms, 602 septillion, which is 1 mole, weighs a gram, or weighs 12 grams. So now, guys, you ready to play a game with me? Probably not. Play along anyway. Guys, what about this? What if you have 2 moles of carbon? Talk to the person next to you about how much that would weigh in grams and how many you would have. Talk about it. What would it weigh? How many would you have? So guys, let's do weight first. Ready? This is logical, right? If 1 mole weighs 12, what does 2 moles weigh? 24, right? If a dozen donuts weighs a pound, 2 dozen weighs 2 pounds. So guys, the logic is this, and I would encourage you to scratch this down. Actually, you know what? Don't. We'll write it down later. Guys, the logic is this. It weighs 24 grams. How did we come up with that? That's 2 times 12. But guys, what is 12? 12 is the formula mass. Guys, here's the deal. Formula mass, listen to the words, formula mass is a conversion. We're about to do dimensional analysis. If 1 weighs 12, if we take 2, that weighs 24. 2 times 12 is 24. Formula mass is a conversion. Now guys, what about this? What if we want to go to atoms? If 1 mole is this, what is 2 moles? What about this? If 1 dozen is 12, what's 2 dozen? 24, multiply by 2. The problem is we got to multiply this ugly number by 2. But guys, the bottom line is it would be 12.04 times 10 to the 23rd atoms because guys, Avogadro's number is also a conversion. And guys, that is how we're going to leverage this information. We are going to use these as conversions. Write this down. Guys, draw these boxes. Then we're going to solve 2 problems and then you're going to work on homework. So guys, hot in the middle of this, the mole. Then, off to the right, mass. The right-hand side of our slide is talking about mass, and guys, that's in grams. No longer in AMUs, because now we're talking about moles. So then, gang, this is the principle that we've established. The conversion between these, and particles goes on the left. And guys, particles include things like atoms, molecules, and formula units. But now guys, let's establish our conversions. How do we get between moles and mass? That's the formula mass. Write that above your line. Then guys, how do we get between moles and particles? That would be Avogadro's number. So guys, we are going to solve two problems using dimensional analysis. And then guys, at that point, it's just time for you to practice. You guys all caught up? Okay, so here's what you want to do. Skip down a couple lines in your notes. Guys, this table that you just built is going to be a lifeline for you at first. Don't defile it. Leave it isolated, leave it clean, and then eventually you'll do these without it. But for now, save that. So guys, write this down with me. Oh, sorry. What is the mass of 2.3 moles of NaCl? What is the mass of 2.3 moles of NaCl? So guys, what we're asking is this. What does this weigh? This is 2.3 moles of NaCl. The question is, what does this weigh? So guys, start without me. Goal, starting point, and line. Read the question, write down your goal. And guys, if you're sitting there thinking, I don't need to participate in this because I got it, that's fine. But guys, understand, come next week, this stuff is going to kick your trash in ways that you have no idea. Again, we're building habits and we're building patterns. Goal, starting point, and line. And then pause. So guys, what are we solving for? What is the mass? So guys, if you are super confused right now and you're going, I have no idea what's going on, allow yourself to let go of the confusion and grab a hold of the process. What is the mass? That's your goal. Grams of NaCl. Then we need a starting point. The starting point will always be the information we're given. How much salt do we have? It's in the problem. How much salt do we have? 2.3 moles. Now guys, draw a line. Some of you right now wrote down 2.3. Some of you wrote down 2.3 moles. And some of you did it right. You wrote down 2.3 moles of NaCl. Guys, again, this is me trying to help you. If you don't write these down completely, you might get away with it today, but next week, you're going to be so confused you have no idea what's going on. And guys, understand, this isn't just because you're in general chemistry. This is what chemists do. This is what her homework looks like all the bloody stinking time. Is it important to label our numbers?
Oh, yes.
I just told him no.
Wait, which numbers?
I'm just kidding.
Okay, I was like, wait, I'm concerned.
So wait, we have to write moles in any...
Oh, every time.
Oh, good.
Every time.
What's up?
I'm just getting a key.
Oh. Okay, so now guys, this. Glance up as I glance down. So guys, what we are trying to do is we are trying to take moles and convert them into grams. So guys, find yourself on your chart. Put your finger on where we're starting. Now put your finger on where we're going. Guys, this is the journey that we're about to take. And in order to do that, the conversion that we need is the formula mass. Oh my gosh, if only you had learned to figure out formula masses. Except for that was the first homework we did today. Right? So guys, let's do this. Let's figure out the formula mass of NaCl. Do it like this. Sodium weighs 23. Chlorine weighs 35.5. Guys, when we add those up, we get this. Please don't write it down. When we add those up, and you can do it in your calculator, 1 mole weighs 58.5 grams. Gosh, if only we knew what to do with that conversion in order to plug it into the dimensional analysis setup. Except for that was the second homework. Guys, if we've got moles on the top, you don't even need to know what the heck a mole is. Guys, if a mole's here, what's got to be down here? Moles. 1 mole. Oh, sure. Call me out on units. Oh, no. No. But guys, this needs to be a fraction equal to 1. So that means the thing that goes on top has got to be equal. So what is equal to 1 mole of NaCl? 58.5 grams of NaCl. Okay, so what did we learn as we were developing that pattern, that rhythm last time? So the next thing we do is we cancel our units. Moles of NaCl cancel with moles of NaCl. Then we ask ourselves this question: are we done? Wait, how did we know so if we're done, then this is the same as this. Sorry, I thought she circled that. Miss Call did the animations. She's so good at circling things, and then she didn't. Darn that girl. Okay, so now guys, we cancel the Na, the moles, and then guys, we know we're done if this is the same as this, and it is, so we do the math. Grab your calculators. So we take 2.3 times 58.5, don't divide by the 1, and we get 134.55 grams. What did she do? Oh, I see what she's doing. It's funny how Miss Call and I teach this differently enough that her transitions don't match the way I would do this. It's fine. It's just different. All right. So guys, now what we need to do is we need to round to significant digits. So how many significant digits are in 2.3? 2. Write it down. And then guys, how many significant digits are in 58.5 grams as 1 mole? Well guys, here's the deal. The 1 never limits significant digits, so this would be 3. So how many digits do we get in our answers? 2. And that would be 130 grams. Questions? Yeah, you're stretching. You guys okay? We're going to do one more, and then you're going to get going on homework. There's one other little twist that I need to show you. You guys good? Okay, one more. It goes like this. How many molecules of water are in 25 grams of water? Oh, man. Oh, wait, there it is. There we go. Okay, guys, this is 25 grams of water. The question is, how many of these dudes are floating around in here? If this is 25 grams of water, how many water molecules are in there? So guys, you get started. What is your goal? What is your starting point? Draw a line. Because what are we solving for? How many molecules of water? We just write it like this, water molecules. Now gang, what do we know about that sample of water? 25 grams, and draw yourself a line. It's funny, Britt, how your animations are different than the way I would approach it. I know. I'm conforming to your process. And the end of the quarter. All right, so guys, this is our journey. Grams to molecules. would you allow your gaze to go up as mine goes down? Put your finger on where you're starting and where you're going. Did you notice your fingers are not close to each other? Guys, we are now going from grams over to particles. So how do we do this? It is a two-step conversion. We've got to go grams to moles and then moles to molecules. So guys, in order to do the first step, we need the formula mass. In order to do the second step, we need Avogadro's number. So guys, let's get started. The first thing we need is the formula mass. The first thing we need, guys, is the formula mass. But gang, now we've got a problem. And the problem is this. Guys, find the mass of hydrogen on your periodic table. What is it? 1.0. Always one decimal place, right? But there's two of them, so that's 2.0. Please write it down. But guys, here's the problem. This is new. Don't miss this. Guys, how many significant digits are there? 3. How many are there? 2. That's bad. Guys, there's an additional rule that says this. We will always go one decimal place. But if this number has more significant digits than this number, we need to go get more numbers off the periodic table. So if this is 3 digits, this has to be 3 digits. So guys, go get another significant digit off your table. What's the mass of hydrogen? 1.01 times 2 is 2.02. Guys, the deal is this. The masses off the table have got to have as many significant digits as the number you're starting with. Now guys, look up oxygen, 15.999 whatever. That rounds to 16.0. That gives us the significant digits that we need. Now guys, we add this up and we get 18.02. So guys, 18.02 grams is 1 mole. What goes on the bottom? The grams or the mole? Grams or moles? Don't even think, guys. What's up here? Grams. What's got to go down there? Grams. That's why you learn the process. If you're lost and none of this makes sense, do the process. 18.02 grams is 1 mole of water. Now guys, we cancel our units. Water drops with water. Are we done? Done? Don't know if we're done. How do we know if we're done? Guys, is this? No. This is moles of water. We want molecules of water. Guys, we're in moles. We got to get to molecules. We got to get to particles. So how do we get to particles? That's Avogadro's number. So guys, it goes like this. Avogadro's number, 1 mole. Which one goes on the bottom? The mole. They cancel top to bottom. So guys, 1 mole of water is Avogadro's number, water molecules. Now we cancel. Now guys, we're done. Water is water. Water molecules is water molecules. So now we've got to do the math. Guys, grab your calculators. I am not going to explain to you how to solve this in your calculators. By this point in your academic career, you should be able to put numbers in your calculator in scientific notation. If you can't, I will help you individually or go talk to your math teachers. But guys, here's the deal. If you are faking this, you're going to get these wrong and you're not even going to know it. I'll show you what I'm talking about. Guys, this is also why I will no longer lend you calculators. It doesn't make any sense for you to learn to do this on mine because I'm not going to give you one ever again. Bring a calculator. No phones. So guys, when we do this math, we get 8.35183 times 10 to the 23rd. If you did not get that number, you need to figure out how to run your calculator. It's 25 divided by 18.02 times Avogadro's number. Now guys, a lot of you right now have 8.35 whatever times 10 to the 24th. That's wrong. It's because you don't know how to do scientific notation in your calculator. We're not going to fix it now. But guys, we're still not done. We need to do significant digits. So 25.0, that's 3 significant digits. 18.02, that's 4 significant digits. And then guys, Avogadro's number is not perfect. That's 3 significant digits. So then we round and we get 3 significant digits, and that would be 8.35 times 10 to the 23rd. So guys, there you have it. I know that there's the possibility that this got weird at the end, not because of the process and not because of the logic, but because you're afraid of your calculator. Guys, set up the problems, do the math. If you're finding that your numbers are wrong, talk to somebody about how to use your calculator. But guys, you need to get these answers correct. So guys, questions about process, questions about what we're doing? So guys, here's the deal. I know that some of you right now are thinking, oh shoot, this just got real. And guys, that's good. You understand that this is not something that you can blow off. But guys, understand we've built a firm foundation. We know how to figure out formula mass. We know how to do dimensional analysis. I talked with you on Wednesday. Make sure you can do this. So guys, we're just bringing those things together. So as you're working on homework, guys, do this. Keep this table in front of you. Literally put your fingers on it. Figure out where you're at and where you're going. Guys, realize these are the only conversions you need today. That's it. Formula mass and Avogadro's number. But guys, here's what we're going to do. Grab your homework packets. Turning to assignment number 3. Guys, we're going to do the odd numbered problems through 21. So guys, now let me put your fears at rest. This will be graded and recorded on Tuesday. No, when? Wednesday. This will be graded and recorded on Wednesday. And then guys, remember how I told you that there's only 2 days in this class where we spend 2 days doing the same thing? Not surprisingly, this is the other day. The other one was drawing Lewis dot structures, do you remember? And so guys, we're going to spend a whole nother day on this on Wednesday. But rather than do another sterile homework assignment, we're going to do an activity. So guys, when you come in on Wednesday, we're going to look over this. Guys, please don't make the mistake of having this unfinished. Get these done. When you need help, come in on Tuesday. And then guys, we will look at this on Wednesday, and then we'll do an activity over these things, which really brings this stuff to life. So guys, we have 15 minutes. Get at least the first 3 or 4 of these done. And guys, when you get into these in panic, trust your processes. This is the same reason that we drill our military over and over and over again to do the same stupid things. Because when the bullets start to fly, you don't want to think. You want to fall back on what you've learned to do. Goal, starting point, line, then conversions, canceling top to bottom. Make sure your remaining units are your goal. Multiply by the top, divide by the bottom, and round to significant digits. Guys, let's get started.